Hey everyone, in this video I'm going to cover two lessons, lesson 3.4 and 3.5. Let's get started with 3.4. So those are like well-known famous functions, x function, x cubed function, x to the fifth power functions. And let me show you more here. And x squared, x to the fourth, x to the sixth power. You don't have to memorize them, but it's good to know them. But even if you forget, as you know, we go to Desmos, right? And you just graph and see. And here, like, you can see how to graph by hand. There are some rules here, so you can follow and graph them. But I choose to use Desmos website to graph them. And here we are, graph each function. Let's say on first one, f(x) equals x to the fifth power minus 2. Again, go to Google, go to desmos.com, excuse me, y equals x to the fifth power, x to the power minus 2. Here we are. That's my graph, right? Here we are. Let's make this smaller. So this is graph A, x to the fifth power minus 2. And let's see, determine largest open interval of the domain over that function, increase or decrease. So as you see here, guys, like this graph has been increasing here, right? So like at this point, my domain, which is x number, is 0. So like increase over 0 to infinity, right? But at the same time, on this side, it has been decreasing, right? And we're gonna say decrease over 0 to negative infinity, right? And so let's have a look at like b here. Let me do b here, x plus 1 to the 6th power x plus 1 to power 6. Yes, let me get this. Let's go over here. So as you see, that's my function, everyone, over here. So this function, so as you see, it has been like decreasing here, right? But here it has been increasing, right? So here, increase here, and it's going to be 0 to negative 1, right? That number is negative 1 because this number is negative 1 here. So negative 1 to infinity is increasing, but on this side it's decrease over negative infinity to negative 1. And also you can do same thing for C. Just graph and see it increase on which part, decrease on which part. And those are your 2 examples. Please graph them by using Desmos website and see where it's increasing and see where it's decreasing. And on this one, we gotta match them. There are 4 equations and 4 graphs. There are some rules here, but based on like ant behavior, but I don't want to do that one. So we can just use Desmos and see it. Okay, now let me check this K first. And we can just use Desmos and do it quickly and easily. Negative x to power 7 plus x minus 4 plus x minus 4. So it's this one. So it's look like, which one is it? It's look like D, right? Yes. So this D should represent kx function, and you can just decide those. Okay, again, there are like official way, which is long way. I don't want to do that one, but just graph and see it corresponds to which one. And same thing over here to graph them. You can use that official way, those long definitions over here if you want to, but again, I prefer to use website. We can just graph clearly, easily. Oops. Oops, where am I? Here. Yeah, just graph and see them. Like same thing over here, to match them, you can graph and see. It's that easy. Here we are. So like I wanna like show you something here. Let me copy paste this over here. Okay, approximate real zeros. Like we're gonna graph some equations. Like zeros means those. Like let me. Okay, okay, I give up on this one. So let's say like we got something like this, right? And my function look like this. Okay, I just make this up, all right? Like my x-intercept, like zeros means solutions, all right? Like what's the solution of this function? Or we can say is x-intercept, all right? So this function, as you see, has so many x-intercept, right? Like this one's x-intercept, this one's x-intercept. So like this function has 4 solutions. Okay, this function has 4 x-intercepts. Or you can say this function has 4 real zeros. Alright? So to find those zeros, what you do is just grab and see those x-intercepts, which is your zeros. Alright, which is your solutions. So I'm gonna do so. So okay. So let me, this one can stay here. Let me graph this. X to the power 4 minus 6x to the 3rd power plus 8x squared plus 2x minus 1. Let me check. X to the 4. Here we are. That's my graph, right? So let me just screenshot of this. Here we are. Okay, I'm gonna show you a solution over here. So what's my x-intercept here? So those are my x-intercept, right? Like this one is over here, this one is over here, one is over here, one is over here. So those are my zeros, right? So like this one should be like, we can approximate. So this one should be like more or less 3.9, right? This one could be like maybe 2.5, maybe 2.424, something like this, right? So this one could be like 0.5, or this one could be like negative 0.9. But you can do like this, or you can say like one solution should be between 3 and 4. This one solution should be between 2 and 3. This one should be between 0 and 1. Or this one should be between 0 and negative 1. You can say so, or you can like approximate like this. You can say like more or less it could be 3.9 and so on. So like we can see zeros of the function by graphing. My x-intercept is going to be my real zeros of the function. And use the theorem to show each polynomial has a function real zero between numbers given. So again, this is like another long way to do so by using this theorem, but I don't want to use that one. So like, which means I'm going to graph this and I'm going to see that my x-intercept is going to be between these two numbers. So we can confirm. So let me do so. 2x squared minus 7x plus 4, right? So as you've seen, this one, guys, as you've seen, okay, let me make it bigger. So this one, as you've seen, 2.7, so which means 2.7, so like it's between 2 and 3, right? So it's confirmed, right? So it's confirmed. So if you graph the other one, like Let me graph other one as well. 3x squared minus x minus 4. If you graph this, x-intercept like this one and this one, as you see, 1.3, so which is between like 1 and 2. So to confirm like those function has a real zero between given numbers, you can just graph and see. Alright, but you can try 49. Alright, so let's move on to next topic, next lesson. Lesson 3.5, rational functions. Like there are so many rational functions, but this is the most famous one, reciprocal function, like 1 over x. This is simplest rational function, 1 over x. Alright, so let me show you this 1 over x. Let's graph this first, and I want to talk about domain and range. Alright, 1 over x. 1 over x. If you graph it, this is how you see it. It looks crazy, right? Here we are. So I want you to see that like all graph has been getting closer to 0. It never becomes 0, because if you put the x0, so it's going to be like 1 over 0, which is undefined, right? So that's why x cannot be equal to 0. So domain could be all numbers, but except 0. 0 to infinity. Okay, like we don't include, we use parentheses, we don't include 0 there, because 0 make it undefined. But in terms of range, so it should be all real numbers. But again, there is no way to make it 0. I'm gonna say same thing. And here we have like there's another reciprocal function, rational function, 1 over x squared. So let's graph this one as well, x squared. This is how it looks like. Okay, make this small a little bit. Here we are. So domain of this function and range of this function. So domain, again, it cannot be 0, which makes it undefined. I'm gonna say this. But range, I want you to see that it will never go down. So there's no way to make it negative number. It won't be negative number. It's going to be always positive numbers. But there's no way to make it 0 either. I'm gonna go 0 to infinity, but you cannot make it 0, so I don't use a bracket, I go with parentheses. And those are your turns, everyone. Please graph them and get your domain and range. And also, like, those are, I want you to pause the video and have a try to solve those as well. And this video is over.